Hi all, a couple more bits of SI unitology before we get into dealing with significant digits. So let me share screen and we'll look at two important points on units. The first thing to note is that when we're dealing with units, if we have something like a joule, it can sometimes be a little inconvenient to talk about, 10 to the 9th joules. And so we have prefixes that express that. So for example, 10 to the 9th joules is a gigajoule. Now, usually we deal with somewhat smaller numbers. For example, a kilo pops up all the time. A kilometer is 10 to the 3rd meters. A centimeter is 10 to the -2 meters. And so those we'll see a lot. So you should be familiar with all of these, both the prefix and the symbols as well. And so, for example, we can put these symbols together. For example, if you're talking about a kilojoule, it would be small letter K, big letter J. That would be a kilo, small letter K for the 10 to the 3rd, and then capital J, joule for joules. And so you should be aware of those prefixes. There's certainly other prefixes that you might see, but on an exam, I'd only expect you to know these. And of course, the exams this year are going to be open book, so you can look them up as well. But it's important to, when you're just reading through text, understand basically what those are, so you know how big something is. What is the difference between a millimeter and a micrometer? That's quite big. A millimeter you can see, a micrometer you can't really see. And a nanometer, that's down at the hundreds of nanometers of the wavelength of light, a couple nanometers of the size of molecules. So you want to be able to know these well enough to be able to read them and recognize how big something is. So those are the important SI prefixes. And one other thing that comes up a lot is temperature. I want to go over this. So there's three common units of temperature. Fahrenheit is what we're used to in the US when we're talking about the temperature. Cook it at 350 degrees. Oh, it's a beautiful day out. It's 72 degrees. Oh, it's so hot. It's 98 degrees. So that's pretty much all it's useful for. In any sort of real engineering or scientific work, it's not that useful. You might happen to have temperatures reported in Fahrenheit, degrees Fahrenheit, which you'll need to convert in between. But in the course of this class, we're going to avoid that extra complication. Degrees Celsius, sometimes called centigrade, but the official name is Celsius, so that's what we use, is much more common. So we know that degrees Celsius, 0 is the freezing point of water and 100 is the boiling point of water. And so you divide that temperature into even intervals in between. There's very straightforward formulas to convert between Fahrenheit and Celsius. I'm sure physical science teachers, probably back to junior high, have tortured you with converting back and forth between Fahrenheit and Celsius. We're not going to worry about that. You know how to do it. I trust you can do that. There might be times in later classes where you'll need to do that conversion. But generally, Celsius is what you'll see temperature measured in various situations. Useful scale for labs. Most thermometers in labs are in Celsius. Another important temperature scale though is Kelvin. So Kelvin units have the same size as Celsius units, but they're offset by 273.15 degrees. Why that amount? Well, absolute 0 on the Celsius scale is minus 273.15. So Kelvin, the degrees are the same size as Celsius, but the reference point is absolute 0 rather than something arbitrary like freezing water. And really that is sort of arbitrary. Like if you're, any other compound, what do they care about where water freezes or boils? And so Kelvin is really a more fundamental measure of temperature. Especially what you'll see in almost all chemical formula, it's Kelvin that you use. Whereas a lot of the data is going to be given in Celsius, just because that's how data is usually taken. So for example, in the ideal gas law, PV equals nRT. You've certainly seen that before, and we'll handle it quite a lot. So yeah, PV and RT. This is only true if the temperature is in Kelvin. If you try to plug a Celsius temperature in, it doesn't work. So that's one important thing throughout the semester is be remembering to convert usually from Celsius to Kelvin. Sometimes you'll want the answer in Celsius, you'll have to convert back. The good thing is it's just a simple offset. So the one thing I'll repeat here that you should remember throughout the semester, almost all chemical formulas use Kelvin. Let me repeat, almost all chemical formulas use Kelvin. Like I said, almost all chemical formulas use Kelvin. So be very aware when you're going back and forth, when you need to go back and forth between the two, and always remember what you should be using. That's it on those last two important bits on units.